Hello, welcome again. We are solving some questions of theory of machine. The topic is dynamic force analysis. Question number 25 and 26 is 6 carries a common statement. The statement is a punching machine carries out 6 holes per minute. Each hole of 40 diameter in 35 thick plate requires 8 Newton meter of energy per square of the sheared area. The punch has a stroke of 95 Question number 25 is find the power of the motor required if the mean speed of the flywheel is 20 meter per second. Question number 26 if the total fluctuation of speed is not to exceed 3% of the mean speed, then mass of the flywheel is. So let us understand this punching operation as this is your hole to be punched and this is the travel of the punch during its forward travel. It travels 95 punch has a stroke of 95 and during its return travel it also travels 95 and actual punching operation as is taking place in 35 because as thickness of hole is your 35 the thickness of hole is your 35 and this requires energy of 8 Newton meter per square. Okay, so now during this travel, okay, so the energy is supplied by the motor to hole directly to hole and energy is supplied by flywheel to hole. So this combined energy is used for making hole. Okay, so the flywheel doesn't have any energy of its own. So whatever energy the flywheel is supplying during this punch during this hole making process uh, is supplied by the motor. So motor will supply the energy to flywheel in rest of the cycle. Okay, so actually the whole of the energy supplied here to the hole is by motor either through flywheel or through or directly. Okay, so now now the energy required, first of all we find out the energy required. So diameter of the hole is given as 40 and thickness of the hole is given as thickness of the plate is given as 35 and energy required is your 8 Newton meter of energy per unit. So this area of hole is pi dt into 8. So pi dt into pi dt, pi d is your 40, t is 35 and t a, that is energy required. So the energy required for one hole is 35186 Newton meter. As it is given that there are 6 holes to be punched in 1 minute, so this complete cycle uh, uh, this complete cycle takes 10 seconds. As 6 holes to be punched in 1 minute, so one hole will be punched in 10 seconds. 6 in 1 minute, 1 in 10 seconds. So this complete cycle will take 10 seconds, and this complete cycle will take energy of 35186 Newton meter. Okay, or energy supplied by motor in 1 second is 35186 by 10 or because this energy has been supplied by the uh, motor either through flywheel or directly in 10 seconds. Okay, so the energy supplied by motor in 1 second will be 35181.6 because this is energy supplied in 10 seconds and in 1 second it will be divided by 10. So that is so power of motor will be 3518.6 watt or 3.1518 1 kilowatt. Okay, so now first question is power of the motor required when the mean speed is of the flywheel is 20 meter per second. So power of the motor we have calculated. So power of motor is 3.5181. Second question is question 26. The fluctuation of speed is not to exceed 3% of mean speed. Then the mass of the flywheel. So this complete cycle takes 10 seconds. Okay, so it means that 190 mm travel of punch takes 10 seconds. So 30, and the motor is supplying energy during whole the cycle, okay, continuously, and this 35 mm will take, if if it is taking 10 seconds, 190 mm taking 10 seconds, then 35 mm will take 10 by 190 into 35, or 1.842 seconds. Okay, so during this so time for this is 1.842 seconds, and motor is supplying energy constantly. The energy supplied by the motor is constant. So during this travel, the motor will supply, as the power of motor is 3.5181 kilowatt. So motor will supply uh, 3518.6 into 1.842 energy, or that is 6481 Newton meter. So energy supplied by motor in 1.842 seconds is 6481 Newton meter, and energy supplied by the flywheel. So this is the energy supplied by the motor, okay, and energy supplied by the flywheel. Total energy required to do one only 35186. So that is the energy supplied during the 35 mm travel, okay, and so rest of the energy will come from flywheel. So that is the fluctuation of the flywheel, energy of the flywheel. So total energy required is 35186, and energy supplied by motor is 6481. So the fluctuation of energy is 28705 Newton meter, and so this is your kinetic energy, or and this fluctuation of energy is given by 2 into k into E, where k is coefficient of fluctuation of speed and E is your mean energy, and 2 is okay. Okay, so now from this E comes out as 478,417. So that fluctuation of speed is given, that is 3% of mean speed, or 0.003. So we can directly use it. So now this energy of the flywheel at mean speed is given as 478,417, and mass of the flywheel, now it, as speed of the flywheel is 20 meter per second. So we can find out mass of flywheel. So mass of flywheel comes out as, equating this energy, equal to half mv square, because this is only the kinetic energy. So kinetic energy is your m, half mv square, and equating it. Okay, so m will be 2392 kg. So answer is 2392 kg. Answer to question number 25 is 3.518 kilowatt, and answer to question number 26 is 2392 kg.